imagine being a little fourth grader with no one to look up to except then Rebecca comes into your life. You know?
How did my kid like?
That is rough. That is very rough. She cussed at you?
He cussed at me.
Oh, they gave you a boy?
Yeah. They gave me a boy.
Oh.
English. I was like, no. How you don't know English, but you know that?
Oh, that's rough. Yes? That's fine. Did you check in with them already?
No, I want to walk now.
Okay. I mean, advisory attendance doesn't really count. So. What? All right. Let's get started. So take a look at your first question. It asks you where it is not continuous. So where will I find x values that my graph will not be continuous in a fraction? Okay, wholes and asymptotes. How do I know which one it is? Well, they're both found on the bottom, but wholes do what? Cancel. So which of these cancel? Now, if it's a whole, does it still count as not being continuous? Yes. Now, does the limit still exist at a whole? Yes, but it would still count as not continuous. Then for this guy, so we have a whole at 2. Then for my x plus 1 that's left over, what feature is that? I think you already said it earlier. Vertical asymptote. And remember, both of those count as not being continuous. Okay, if you care, which I'm sure that you probably don't, any factors left on the top are x-intercepts. Okay, so those are continuous and they're no problem. Okay, go down to number 11. We want our graph of f to be concave down. What version of f do I care about for concavity? F prime, or f double prime? Double prime. So if my f has an antiderivative in it, then when I go to f prime, what's going to happen when I take the derivative of the antiderivative? They cancel each other out and I do a letter swap, right? So my x is going to replace all of these t's. Quick question, will I need chain rule? No, because my x on the end point was already alone. And what's the derivative of a loner x? Just a times 1. Okay, then from there, take the derivative again. So we do 3 times 2 is going to be 6x squared. 2 times 15 is 30x. That'd just be a 36. And then remember to do your number line, you should set it equal to 0, factor, blah, blah, blah. So what can we take out of those guys? 6. That's a x squared minus 30 divided by 6 is a 5. Oops. And then 36 divided by 6 is a 6. So I need numbers that will multiply to 6. And now question, do they need to add or subtract to 5? Subtract means I have 1 positive and 1 negative. That would not multiply to a plus 6. So if this is a positive 6, my numbers have to be the same sign so that I can keep a positive here. So they have to add to 5. So what do I want? 2 and 3. Very good. Now it'd be a minus 2 and a minus 3. Okay, but remember, if that third number is a plus, your signs have to match. So number line it over here. 2 and 3 go on your number line. Should I include a 0 for the 6 on the outside? No, because it doesn't have an x with it. Very good. Okay, then bigger than 3, let's say I pick 4. 4 minus 3 positive, 4 minus 2 positive. Are any of these double roots that they can't switch sign? Double roots meaning they have a squared on them? No, then I know it'll go plus minus. Concave down would be the section, oops, that came out negative, which would be 2 to 3. Good? All right, next one says, for which of these is the limit, I'm going to write this a little bit bigger, as x approaches infinity equal to 0. How do I do limits to infinity? What rules? Bobo, Bot, and Betsy. And if I want it to come out to 0, what type does it have to be? a bobo. So I'm looking for which of these are a bobo. The first one is an ln versus an x to the 99. Is it a bobo? Actually, let's write our powers out. I know you have that big packet, but remember logs and natural logs are the smallest, then powers, then exponentials. And then actually I forgot the real smallest would be a constant or a sine or a cosine. And if you're wondering why sine and cosine basically count as constants, it's because remember, sine and cosine go 1 to -1, 1 to -1. So they don't really grow the same as other graphs do. Okay, so now I'm comparing ln, which is a log, to x99. What does that qualify as? That would be a power, which means it's a bobo. What about the next one? That is a botan. E to the x is bigger and it's on top. And then for my last one, that is a bobo. Okay, remember that x to the 99 is a power, but 99 to the x would have been an exponential. So if the x is the base, it's a power. If the x is the exponent, that makes it exponential. So we want 1 and 3. Answer choice E. Okay. And then I don't know if I've told y'all this, but a couple years ago, they eliminated the option E. So you are only going to have an A, B, C, D. You won't even have a 5th answer choice anymore. Okay, next one. It says f of 0 is -5 and f prime is less than or equal to 3. Of the following, which is not a possible value for f of 2. Let's make ourselves a little chart here. At 0, what is f of x? -5. And I want to know what f of 2 could be. Okay, so what's between 0 and 2 here? Let's fill in the gap. 1. Now, if I know that my f prime is always less than 3, what is that telling me about f, if it's f prime? Slope. The slope has to always be less than or equal to 3. Then the biggest jump that it can make would be a 3, right? Because that's the slope. So from 0 to 1, if it jumps 3, which is the biggest it could jump, what would this be? And then if it jumps 3 again, which is the biggest possible slope that it could jump, where would it end up at? 1. So what could be the biggest possible value? Or which one is not a possible value? Okay, there's no way it could have gotten to 2. Because if the biggest jump it can make is a 3, okay, then we couldn't get past 1. Now, quick question. Does this tell me the function's always increasing? A slope of less than 3 could include negatives. So it could go down to -10 or -5, because even a negative slope would still fit this criteria, that negative numbers also count as less. Okay, I want to skip down to the bottom one here. We have this. What does it mean? Inverse. And remember, okay, you're probably going to get one of these on your test, which is why I just want to go over it again. Okay, for inverses, there are 2 relationships that you need to know. Okay, the first one is that their ordered pairs are backwards. And the second one is that their slopes are reciprocals. So it tells me that for all x's, 0, 1 is on the graph of f. Where do I put 0, 1? Left or right if it's for f? Left. What does that make the ordered pair for g? 1, 0. Okay, then it's asking me for g prime of 1, which means that I want the slope. But in order for me to find the slope for g, I'm going to need to find the slope for f and then flip it. So how would I find the slope for f? What would I need to do? Take the derivative and then plug in f's x value, which is what? 0. So let's do that. We have our f right here. What's f prime? 2x will go to a 2. E to the x will stay its own self. Then I'm gonna plug in my 0, which means that I have 2 plus e to the 0. E to the 0 is what? 2 plus 1 means my slope is 3. Then what's my slope on this side? 1/3. Okay. So it'd have to be B. Okay, but remember, their ordered pairs are backwards, and their slope at those corresponding points are flipped. All right, let's go back to up to number 18, right above that. Okay, you have x's and y's that are all jumbled together in the same equation, and you're asked to find dy dx. Okay, now this one's a little bit tricky because your ln has a bunch of different stuff in it. So real quick, let's just review. What's the derivative of 1 over x? Or wait, hold on, wrong, dang. What's the derivative of ln x? 1 over x. Okay, so then what would be the derivative of ln u? Where u is like x stuff, but it's not just an x. 1 over u, but then you'd have to remember to multiply by whatever the u prime is. That's the rule that we're going to use here. So if it's ln of some crap, it's going to be 1 over that crap, but then don't forget chain rule. You're going to have to multiply the derivative behind it. So for this one, my ln has a what inside it? So then the derivative of that would be 1 over 2x plus y times. And then now I need to multiply by the derivative of 2x plus y. What's the derivative of 2x? What's the derivative of plus y? dy dx. Very good. Okay, then on the other side, x plus 1, what would the derivative of that be? 1. Okay, and then remember that for the second one, the derivative just goes to 0. Okay, now normally I would recommend that if you have something on the outside of parentheses that you would times it in. But if this is a fraction, what would be an easier way for me to get rid of that? Multiply it on both sides. So if I have a divide by 2x plus y on both sides, I'm going to multiply that onto both sides. So these guys will cross out. But another strategy would be you also could times this inside. Sometimes that's easier. Okay, from here, I have 2 plus dy dx equals 1 times 2x plus y. It's just a 2x plus y. Then I'm trying to get my dy dx by itself. So what do we still need to do? Minus that 2 across. Which means that we want a 2x plus y minus 2, which is answer choice B is correct. Good on that? All right, go ahead and turn the page. All right, let's do the bottom one first. What's it asking us for here? Okay, absolute minimum. So what do we need to do? Take the derivative, find our critical numbers. But then for an absolute minimum, is the line chart enough? What do we need to do at the end? Very good, candidates chart. So let's go ahead and do it. Let's start by taking the derivative. So if this is g, the derivative of that would be called g prime. 3 times 4 to the front is a 12x squared. Next one is plus, then minus 6. Then we can take out a 6 from there. That's going to give us a 2x squared. 6 is now a 1x and a minus 1. Okay, I'm going to actually do an AC chart on this just because I have a 2 in this spot. So A, B, C. Remember, you want to times the A and the C together. 2 times -1 is -2. And then my 1 here is on the bottom for my basement number. What's the only way to times to get to 2? 2 times 1 But then if I'm trying to keep this one at the bottom positive, I need to make sure I put my minus on the smaller number, which means it's going to go here. Okay. Then remember, from there, you should take that 2 and you'll go like this. So it'd be, if this is an A, you divide by 2. 2 divided by 2 gives me what here? X plus 1. And then this would be an X minus a half. And then do you remember, if you can't divide it, you slide it. That was like the little trick that I did in algebra 2. So that'd go to a 2x minus 1. Okay. So if you have an A, divide it onto your factors. And if it won't divide fully, just slide it to the front. But if you have another way of doing this, like box method or whatever, that's fine. Okay, from here, my critical numbers are what? -1 and 1/2. And then we'll put them in our chart. Remember, not only do the critical numbers need to go in the chart, what else needs to go in the chart? The endpoints. So -2 and 1, -1 and a half. Then you'll take each of those numbers one at a time, and where are you plugging them back into? The original. Very good. So my g of x here is a 4x cubed 3x squared minus 6x plus 1. So let's do 1 first. 4 times 1 is 4, plus 3 is 7, minus 6 is 1, plus 1 is 2. Okay, let's do -1 next. -1 cubed is going to turn my 4 negative. -1 squared is going to turn it positive, so a plus 3. What about a -1 times a -6? That'll be a plus 6 and then a plus 1. So I have 3 plus 6 is 9, plus 1 is 10, minus 4 would be a 6. Okay, next one's a -2. Cubed would be 4 times -8. -2 squared would be 3 times 4. Minus 6 times -2 plus 1. That'd be a -32. Okay, -32 plus 12. Another plus 12. Plus 1. So that'd be 24, 25, and then we need to take away 32 would be -7. Okay, and then we have one more left to do for a half, sadly. So it'd be 4 times a half cubed, 3 times a half squared, 6 times a half plus 1. Half cubed, don't forget to cube the top and the bottom. So 1 cubed stays a 1, 2 cubed turns to a what? So 4 times 1/8 would be a half. Half squared here would be a 1/4 of 3 would be a 3/4. Then half of 6 is a -3 and then a plus 1. Now, don't get caught up in finding this exact value. Could it be less than -7? Like, look at the numbers. That's a 0.5, 0.75, and I'm only taking away how much? 3. There's no way this is smaller, so it's got to be -7. Now, could you spend the time in figuring it out? Sure, but remember, it's a time test. So once I see these are little tiny numbers, I know it's not going to beat that because I'm looking for a minute. Okay? All right, go ahead and let's do the one right above that. Okay, so we're given a graph. What's in the graph? What function? G of x, and they're asking me for h prime. So we got to look in the question to see what the relationship is between h and g. So it tells me right here that my h of x is going to be the multiplication of e to the x and g of x, which I have a graph for. If h is these guys multiplied together, and I want H prime, that means I need to take the derivative of two things times together. What rule is that? Product rule, very good. So my U is going to be an e to the x. My V is a g of x. And then we're taking those derivatives, doing our cross product. What's the derivative of e to the x? Its own self. V prime will go to g prime of x. And then I'm ready to do my diagonals. Remember, product rules of plus in the middle. So it'll be e to the x times g plus e to the x times g prime. Then where do we want the derivative at? H prime at what? -1. So this is going to be e to the -1 times g of -1 plus e to the -1 times g prime at -1. Okay, then the question is, how am I going to use the graph of g to find both of these? What feature will g be if I'm looking at the graph of g? Y value, what will g prime be? Slope. And remember, you can only count a slope of a straight line, but do you notice they gave you a straight line at -1 for you to count the slope? So at -1, what's the y value? 3, so it's e to the -1 times 3. And then for my g prime, I want to count out the slope of that. It looks like it'd be down 6 and over 1. Down 6 and over 1 would be a -6 slope. Okay, then you'll notice there, which one do you want? Oh, if they both have an e to the -1, do you remember you can pull that out? So let's do this. E to the -1 means now it's a 3 minus 6. Okay, if they both have it, pull it out to the front. 3 minus 6 is a -3. And then you'll notice that rather than leaving the e with a -1 power on it, they just pushed it back down to the bottom. Okay. All right, last one we're going to do is the little graph right here. Skip one page, number 79. Okay, this is a graph of f prime. And I want you to use that to see which of these could be f. So if this is f prime, where will I find mins and maxes for the original function f on an f prime graph? Where it passes through the x-axis. Very good. So it crosses the x-axis here and here. Will 2 be a max, a min, or neither? 2 will be a max. And what will 3 be? Min. So which of those f graphs has a max at 2 and a min at 3? D does, and C. Okay, 2 barely has a max and a min, but it does have them. So A is out, B is out, and E is out. Okay, out of the 2 remaining graphs, do you notice that at 0 and at 4, you do have touching 0? That means it almost has another min or max, but it doesn't fully pass through. So looking at these 2 graphs at the ends, which ones go flat, like they're about to have another min or a max, but then it actually doesn't? C is your right one. Okay. One more way that you can tell that is, what will concavity be on the original graph, the f prime graph? So if I look at my graph, my slope is up, down, up, then I would want to see my graph be concave up, down, and then up. So that's another way that you can check your f prime to your original f, is that the slope here is the concavity here, which is also a match. Okay? Good job. You guys are going to do great. Don't lose your calculators, and then give me your practice test on Monday after your AP test.